Hello, I'm Bob Hinden. This is Oli Tron with Six-Man Chairs. Welcome to IETF 109, first of two six-man sessions. So using Meet Echo, if you haven't read the procedures, if you want to, when we get to a discussion, if you want to be recognized, press the raise hand thing, and then we'll tell you to talk. And then you can turn on your audio or video. And it'll be good to propose that for the speakers that you turn on your video. And if that somehow interferes with the session, we'll say so. But you'll also need to turn on your audio and video. It's the icons in the upper right. So why don't we get started? So this is so here's the meeting notes, how to use Meet Echo, and remember to state your name when you speak. Blue sheets are automatic this time by logging in, and the notes are on Code Mid, however you say that, in a separate window, and you can join the Jabber room by also clicking on the chat icon. And what I do is click on the move to a separate window and move it out of the way of the main presentation. Okay, next slide. So this is the Know Well. We trust you have agreed to this, and I won't read it. You should have it memorized by now. Next slide. We have a question. Edward, go ahead. You have to turn on your video or audio, sorry.
We seem to have left the queue, so
okay.
I guess we'll just move on.
Yes, it's easy to press the wrong button. So we're Jabber room is automatic this time. We do not have a Jabber scribe, but I think that will be okay. You know, we're both watching the Jabber room, so if anything has anything to raise, you can still use it. We didn't update this. Barbara and Su Ping are going to work on minutes, and this is a link for presentations. Next slide. So again, we have two sessions. We're doing mostly the new internet drafts this time, and you can all read this. So some of these have had some discussion on the list, some have not, but we wanted to give the speakers a chance. As we said, we got two 2-hour sessions for this meeting. Next slide. And this is the Friday session. We have, we'll do an introduction. We'll have a report of the source routing, basically the spring design team report, 2 working group drafts, the minimum path and minimum MTU hop by hop option, and application of alternate marking method, and then 1 new draft that the request for a slot came in late, so we put that at the end of the session. Next slide.
Okay, so, yes. So the document status update since the last meeting. We have published 1 RFC. That's the ICMP limits document that Tom Herbert authored, 8883. We have nothing in the RFC editor queue, and we have 3 documents submitted to the IESG. It's the temporary addresses base document, it's the gratuitous neighbor discovery document that Jen authored, and it's the OEM document for segment routing that Safar authored. So those are just quite recently advanced to the ISG, so it will be a little while, I think, before Eric gets to them and they continue through the process. Then we have no documents in working group last call, so we cleaned off our slate quite well. And we have 3 documents in working group that we work on currently. It's the PathMTU hop by hop option that Bob and Gori will talk about later. It's the alternate marking method that Giuseppe will talk about on Friday. And it's the improving the robustness of stateless address also configuration by Fernando. That's not on the agenda for this meeting. We have a report on Friday for the design team, the SR design team that is working on compact routing headers as a sort of a follow-on work on the segment routing stuff that Sixman has been doing for a while. They have a session on Friday morning, just before Sixman on Friday, going through the design team work. So that's certainly worth joining that session as well before they come and give a readout of the status on Friday. That obviously affects, that's kind of this CRH document that Ron has that has been left in stasis, awaiting the decision from the design team. So Fred Templin, I believe you are up. Let me get your slides. So Fred is going to talk about the IP6 neighbor option for the Omni draft. We're not presenting the main draft here, but only the neighbor discovery option. So Fred, you've unmuted yourself. The floor is yours.
Do you hear me?
We can hear you fine.
Okay. I'll send video too. Not that I'm the prettiest looking person to look at, but there it is.
Okay.
So
Solely not seeing
whenever-
the slides yet.
You're not seeing the slides.
Is anyone else seeing them? Or Fred, can you see them?
I don't see slides.
I can't see them changing either. Let me disable and start again the sharing. There you can see them, right?
That's better. Good. So go ahead, Fred.
Okay, so this is a draft on IP version 6 neighbor discovery overlay multi-link network interface option, a new IPv6 neighbor discovery option. Next chart, please. So the draft title here is draft template 6-man Omni option. It is specifying a new IPv6 neighbor discovery option type, and it's requesting an IANA assignment for that type, for that option. The option body contains TLV format sub-options, and this document defines an initial set. The option may occur in any IPv6 neighbor discovery message, being router solicitation, advertisement, neighbor solicitation, neighbor advertisement. Nodes that recognize the option apply Omni conventions. Nodes that do not recognize the option simply ignore it. And the IANA assigned value allows immediate option recognition in a single octet compare. In other words, just check the type. And that determines whether the peer understands Omni without having to look more deeply into the option. So it's a faster processing thing, the fact that we've got a unique type value for this option. Next chart, please. So the overlay multi-network interface option is essentially type and length are the same for standard IPv6 neighbor discovery messages. We have a prefix length field, source target index field, and then the sub options can follow immediately after the first 4 octets. Next chart, please. By the way, there's a tab that says Olatron screen that obscures some of my chart. Is there a way to turn that off?
That only shows up. Move your mouse somewhere else on the display. That's just local to you.
Okay. Yeah, I can't seem to lose that. I'll work around it. It's okay.
Or resize your browser, perhaps, if that helps.
I think I'll be okay. It's
okay.
It's somewhat transparent, so I can see through it a little bit.
But it's local to you. It's not everywhere.
Okay, that's fine then. Okay, so in the Omni option header, we have a type field which is set to TBD, and this is where we're requesting the IANA value for the type. The length is set to the number of 8-octet blocks, the same as for any IPv6 neighbor discovery option type. Prefix length is a 1-octet field that encodes a value between 0 and 128 as a prefix length for the IPv6 source or destination address of the neighbor discovery message. The prefix length is set to the length of the prefix for addresses that include a global or unique local prefix, and for other address types, it's simply set to 128. The source target OM index field is a 1-octet field that encodes a value between 0 and 255 that identifies the source or target underlying interface for the IPv6 neighbor discovery message. Remember, it's called overlay multi-link network interface, which means it's an overlay over underlying interfaces. And this field tells which underlying interface that the message is either going out over or coming in on. That's why it's called source target. And then again, the sub options is a variable length field of length such that the complete Omni option is an integer multiple of 8 octets long. Next chart, please. So the Omni option may appear in any IPv6 neighbor discovery message type. It is processed by interfaces that recognize the option and ignored by all other interfaces. If a single IPv6 neighbor discovery message contains multiple Omni options, the first one is processed and any additional options are ignored. So an Omni option may include full or partial information for the neighbor. If it includes full information, its contents provide new information and or update any previously cached information. If it includes only partial information, it updates the corresponding cached information, so that's the union of the most recently received Omni options that define the state that's been established by the Omni options. Next chart, please. So the Omni sub-option format, the sub-option contains 0 or more sub-options. Each one is concatenated immediately after its predecessor. All sub-options except pad 1 are of type length value encoded format. So you have a subtype, sublength, and sub-option data. Now the data here is not an integral number of 8-octet bytes. It's an arbitrary number of bytes, and the sublength is just a byte count. It's not an number of octobytes. Again, the sub-option data is a block of data with a format determined by the subtype. Next chart, please. This document defines the following sub-options. Pad 1, which is the one that we're very familiar with, is 1 octet of 0 padding. Pad n is n octets of 0 padding. Sub-option number 2 is interface attributes type 1. Sub-options 3 through 252 are available for future assignment. 253 through 254 are reserved for experimentation, and 255 is reserved by IANA. And other documents may define new subtypes. Next chart, please. So the first subtype that we have that is defined is called the interface attributes subtype. And this is a type 1 interface attributes. The interface attributes contains, again, subtype and sublength. Then it contains a Omni index, Omni type, provider ID, link metric, a reserve field, and then a set of preferences for the 64 DSCP codes that tells what the preference is for each of those DSCPs for sending packets over that interface. And those preferences are encoded as low, medium, high, or disabled. And that gives an indication to the IP layer which underlying interface among potentially multiple the packet should be destined to. So again, this is a interface attributes type. There may be multiple of these in an Omni option if you have multiple underlying interfaces, and each underlying interface is differentiated by the OM index octet. Next chart, please.
Fred, do you want to take a question from our AD? Eric Klein is in the queue before moving on.
Sure, go ahead. Go ahead, Eric.
You just need to unmute yourself, Eric. We can't hear you.
Unmuted.
We could.
It appears you can hear me. I see the.
Yeah,
Yeah.
we can hear you now.
You're a little faint.
Did you mean to say DSCP in the document? I noticed DSCP, but should these be RIO preference instead, since they're 2 bits and not 6 bits?
Well, the encoding of these bits takes on the values 0 for disabled, 1 for low, 2 for medium, and 3 for high. And that's a preference for example, P00 corresponds to DSCP 0. P01 corresponds to DSCP 1. And each one of those 2-bit fields gives a disabled, low, medium, high. And it corresponds to the DSCP value that appears in the IP header of the packet that's being examined by the forwarding.
I see. Sorry, thanks.
Okay. Okay, so now in this interface attributes, subtype is set to 2. If multiple instances with different OM index values appear in the same Omni option, all are processed. If multiple instances with the same OM index value appear, the first is processed and all others are ignored. The sub length is again set to a value n from 1 to 255, and encodes the number of sub option octet data octets that follow. OM index is a 1 octet field that encodes a value from 0 to 255, identifying the underlying interface for which the interface attributes apply. OM type is a 1 octet field that encodes a value that corresponds to the type of the underlying interface. For example, Ethernet or Wi-Fi or cellular, whatever the underlying interface happens to be, there's a type value. Next chart, please. Provider ID is a 1 octet field that contains a value from 0 to 255 corresponding to the underlying interface identified by OM index. And again, link is a 4-bit link metric. The value 0 means the link is down, and the remaining values mean that the link is up, with metrics ranging from 1, meaning lowest, to 15, which is highest. And then again, the 16 octet preferences field, which we just discussed with Eric's question, immediately follows the reserve field with values P00 through P63 corresponding to the 64 differentiated service code point values. And again, each 2-bit field includes disabled, low, medium, or high, which is the preference for sending packets that have that DSCP value over that particular underlying interface. Next chart, please. So sub-options that may be defined in future documents include type 2 interface attributes, traffic selector, mobility service register and release sub-options, network access identifier, geographical coordinates, and DHCP unique identifier. And I won't get into what those are used for. That's in future documents. We'll be looking to define these new sub-option types. Next chart, please. So in IANA considers, what we're asking is that the IANA allocate a type number for the registry IPv6 neighbor discovery option formats for the Omni option as a provisional registration in accordance with RFC 8126. The Omni option also defines an 8-bit subtype field for which the IANA is going to be instructed to create and maintain a new registry entitled Omni option subtype values. And the initial values from the Omni option subtype values registry are given, well, it says given below, but the document contains the values. And then again, future assignments are to be made through expert review according to RFC 8126. Next chart, please. I'm already to the end. I don't know if we're out of time or whether we still have time, but the final question I had.
We have time for discussion.
Okay. Should I ask for questions then?
Yes.
Yep.
So if you're interested in saying, oh, Dave Thaler, go ahead.
Dave, if you can hear me, go ahead.
Okay.
Just checking. Can you guys hear me?
We can hear you.
Yes. And
Okay,
see
great.
you.
Yeah, so it looks to me like the main use of this option is for Omni interfaces. I mean, I was trying to figure out what problem you're trying to solve since you didn't actually present that in here. So I was looking at the draft as you were presenting while I was kind of following along where you were presenting in the draft. And the draft talks about that the problem being solved is in the Omni interfaces one. And so first, a clarifying question, where is the Omni interfaces draft? But don't answer it yet, because I'm just going to get all my questions on the table here first, and then you can answer. I understand you're saying it could be usable by other interfaces, but if I was looking for what problem you're trying to solve, where would I look, and which draft is that? Because I think what problem you're trying to solve, if there's a draft in the working group, then the working group document should also have what problem it's trying to solve. That's my meta question. And then the last comment is, if I remember correctly, the allocation policy for ND option numbers is RFC required, right? It's not IETF consensus. It's not, anything else. So even you can get this, even if it were to be an independent track RFC. And so even if the answer is no on the adopt as a 6-man working group item, it doesn't mean that you can't get the actual option and use it. The real question is, would there be multiple interoperability implementations from enough people to warrant a working group item? All right, that's the end of my questions. I'll stop.
Okay. So Dave, you're right. There is a different draft that's called the Omni draft that's different than this draft. And that is a full explanation of the Omni interface and the Omni link and all those aspects. This document is strictly looking for the assignment, the allocation of the option. Now, I think one of your other questions had to do with whether there's an RFC required for obtaining an IPv6 neighbor discovery option, and that's the purpose of publishing this document is to have an RFC number so that we can have an IANA assignment of the option number in conjunction with the RFC.
Yeah, I guess my point is that you don't need it to be a 6-man working group item in order to get a number. You just need an RFC, which could even happen through the independent stream through the RFC editor submission process. So the question is really, what is the rationale for adopting as a 6-man working group item as opposed to independent? And that would be, if there's sufficient interest in having multiple interoperable standards-based implementations, and the answer might be yes. But I can't tell for sure yet, given that I don't fully understand the problem you're trying to solve. I kind of can guess at some of it because I understand you're trying to address a multi-link subnet style thing, and so I could kind of read some of that into it, but it wasn't documented in the draft of this presentation. And so my point is just whatever the problem is that we're trying to solve, then it should either be in the draft or in a draft in the same place, whether that's a 6-man working group draft or a RFC editor, independent submission stream or whatever. So, but it sounds like you're saying, yes, you're doing this so that you can get a number, which I'm saying you could do without having it be adopted as a 6-man working group item.
I understand your point, Dave, and it had not occurred to me, and it's a valid point, and I think I should probably drop back and discuss with perhaps some of the area directors or chairs as to what's the right way to go. Or maybe I should just ask the chairs, now that Dave has brought up this other possibility, should I even be asking this question today?
Well, so first of all, Oli started there's a show of hands tool. Basically, we wanted to see how many people have read the draft. So if people could use the tool and indicate that. Raise your hand if you read it. Do not raise your hand if you want to say you didn't. I read it.
Have you raised your hand?
I did.
Yeah. So far we have 5 raised hands out of 93 participants, which is likely that we would have to take this question to the list anyway, just and encourage people to read both documents before we can answer that question, I think. But yes, I also think we should, well, perhaps based on that, we should, or what happens with that, we can discuss Dave's suggestion as well, what the avenues, what the best avenues are, depending on the interest here. So we're up to 7 now. This is, exciting. Any other questions for Fred? Well, you can just leave this open for a little while until people figure out how to use the tool. No further comments?
Okay, I think that's it for me then, correct?
Yes, I think we'll take that question to the list and continue discussing, between our ADs and chairs, Fred, if that's okay with you. Thanks a lot.
I think it's okay for me. Thank you.
Yeah. And by the way, I think someone asked in the Jabber room, but it's actually recorded. So there's 92 participants. 7 people said they read the draft and 17 said they didn't. So, okay, thank you.
7's a good number. Okay, thank you. Bye now.
Looks like I have to
And
share my screen again for some reason. I didn't like my setup with preview. I did try that before the weekend, so.
Okay, go ahead.
Okay, so I guess I'll jump into the pink box, take off my chair hat. Bob is left as the sole chair of this one. This is the a presentation of the universal configuration information option, which is a draft that I presented back in IETF 104. In the meantime, there has been some developments in this area. We have gotten a new co-author, so Tim Winters have joined in working on this draft, which is greatly appreciated. I'll be presenting this. Tim is hopefully here to help me out. Apparently, he's a little tired. After the discussion we had, we moved it from experimental status to proposed standard status, and we've added DHCP-v6 support as well, and some more details on that in the following slides. So the problem this is looking at is twofold. It's partly how we do new options in the working group, that we're spending an inordinate amount of time arguing over relatively simple new configuration information options, and where we also end up being split halfway between the people who need it and the other people who think you shouldn't need it. And so this document proposes a slightly different approach to how you can do configuration information options in the IETF. And the solution it proposes is basically to use a modeling language and a self-describing data format, which also has the, or should have the implications of implementations that they no longer need to change code to add support for new options. Well, not at the network side, at least. That's the idea. Yeah, so the technical idea here is that the option should use a self-describing option format, where on the router or network side, for example, the operator just specifies new JSON objects. Those are modeled in CDDL, and encoded in CBOR is the proposal. We had some discussion on that leading up to IETF 104, and that would allow new options to be added without changes in the router OS or in the host OS for that matter. You could have applications just subscribing to keys in the all those objects that the application is interested in. For the process changes, the idea is now that since the option space is not really a constrained resource anymore, there isn't any good justification for the IETF to manage the number space. And somewhat depending on what the options are, the idea here, and this is why it was experimental initially as well, was to see what would happen if we open this up and allow the as long as you had a CDDL going in the IANA registry, the option was essentially implementable, although you could argue that the semantics of it required more documentation. So the idea here is to put in some more text perhaps around what the IANA registry, its expert review at the moment of how involved that could be, and if the expert could then punt to the working group if more specification was required. So it's essentially making use of the router advertisement under the HPV6 as a generic carrier for this this option. It's useful for in the RA case. It's certainly useful for one-to-many communication, but you can also use it as you can with RA for one-to-one, either with a unicast RA or if you're on a point-to-point link. As I said, CBOR with CDDL of JSON objects. The format here is unchanged from IETF 104 revision. We obviously ask for type code 42 since this is the universal answer to any other option. Unfortunately, when we made this generic and usable for DHCP as well, option 42 is taken, so we might have to obsolete RFC 4833, which is some time option to get number 42. That is a joke, by the way. Here's some examples of how this can look like. We're suggesting that you put all the IETF sanctioned objects under the IETF key, and then other private users as well is allowed within this format outside of the IETF object. So this is just simply text-based, as with JSON. And this is an example of the CDDL, how that would look like. Of question mark is the optional entries. You can specify ranges and limits, for example, for prefix length. Dave, please go ahead.
If you're almost done, I can wait, but I have a question about multiple slides here. So do you want to finish, or do you want me to ask now?
No, I think we can just evolve this as we go. So please go ahead.
Yeah. So first of all, I want to say I really like this idea of the universal option of something that can be encoded the same blob in DHCP and RA, and so overall, I am in favor of this approach. I don't know if that's a contentious point, but I just want to add support for this. However, the way that it's being done, since, as you point out, that there's issues with length, you can only encode so much stuff. The choice of JSON rather than native CBOR seems questionable to me. So, like on the previous slide, if you go back one, you see that the RDNSS, you can see the IPv6 addresses are encoded in text format. You see the labels RDNSS as text format. Go forward one slide. In the CDDL, right, normally the labels in the map, right, PBD : DNS : and so on in CBOR, normally those would be nice short integers as opposed to big long strings. And so using JSON and T-sters for things like you can see prefix as a T-stir, can be much larger, and so it limits the applicability as opposed to just using CBOR directly without JSON. And so I'm in favor of this approach, but I would be in favor of it even more if you deleted all the JSON stuff and said just use CBOR.
So this is, I'm not the expert on this. I've been speaking to Carson a bit. Am I right in that you could very well specify this CDDL with the IPv6 address and prefix tags, and still have a JSON representation? It would still be easy for a JSON, an implementation to map from a JSON object into that CBOR representation, as long as the CDDL specified the address tags. Is that? You agree with that?
So you're taking an approach that's very similar to what one of the other working groups that I participate in did, where they were designing a protocol and they wanted to allow, originally use both JSON and CBOR, kind of your choice, and pass, like a media type or something, because this wasn't an IPv6 option. It wasn't that low a level. And eventually the working group concluded that let's just delete all the JSON stuff, because it's actually much more cumbersome to use compared to just using CBOR. By cumbersome, I just mean bloated, right? And I don't think it provides you any value other than readability, and I don't know that readability is actually important for an ND option, since none of the other ones are text-based. And so in the maps here, right, the CBOR map is basically a tuple of two TLV encoded things. And so the thing to the left of the colon is one value, and the thing to the right of the colon is another value. So it's basically like an array of size 2, where you have something to the left, something to the right. So you can put a string on the left, okay? So the keys of your map could be a string, but normal CBOR stuff tends to put integers there, which is more compact. And so they're both unique, and you need a registry for them in IANA either way so that you don't have collisions. And so all I'm saying is I don't see the value in using JSON as the native object format. If you just specified it with CBOR, it would be both more compact, hence more widely applicable, meaning you could pack more stuff into the same ND message. And I don't think the JSON buys you anything. So anyway, that's just me arguing that you should delete the JSON stuff, but otherwise I love it, and the CDDL here looks fine. It's just the left sides of the colon you'd assign integer values to, and those would be integers in a registry you define.
That's a very good point, Dave, and I think I don't think we disagree, because JSON is really there more as an example of the user-side representation, if you like, than what's going on the wire. And
we did the same thing too in the TEEP working group. We started exactly the same way. I can see you going along the same path, and I'm saying, jump to the end, jump to the end.
Yeah, that's a good point. Thank you.
Okay, Brian Carpenter, next. We see you.
Can you hear me?
Yes.
We can hear you.
Okay, good. First time it didn't work for some reason. I really wanted to say +1 today, but this is more or less what we've done and grasped in the animal working group. And there is nothing you can't do because of restricting yourself to CBOR. And if someone really wants to do JSON, they basically just stuff the JSON into CBOR, and it arrives at the other end in good shape. So it really is more powerful to say CBOR.
Okay, excellent. So again, I was thinking, since the mapping between CBOR and JSON is easy, then the natural choice here, I think, for a router CLI, if you were taking that as an example, would be to give, type in JSON objects, and the CBOR would come out.
I'm pretty sure that exists as a web service already.
Yeah.
This is easy stuff. I've done most of my code in Python, and in Python it's just seamless.
Yeah. Well, thanks for supporting Dave on that. That sounds like we should clean that up.
Okay, Andrew.
I also just wanted to say that I definitely prefer the straight CBOR option rather than the JSON. Not really a fan of having to process strings, etc., and the bloat that they bring. So yeah, I'd also just want to second that.
Okay, good. Sounds like we have a clear task then of fixing that. Okay, so let me. I see, Brian, you're back in. No, the queue is done, and see how if it times out. So the suggestion is to have a new IANA registry then for the CR option. We have the CDDL going directly in the registry. So you could, for simple options, you could just have the IANA registry without any further, RFC or any IETF work done. And this should have expert review. And I think the expert should have the option. We should write some guidance text, I think, for the expert review, where he could or she could punt to the working group or to the IETF or decide that an IETF document would be required for the particular option, depending on the semantics of the option. Lorenzo. Lorenzo, do you want to go ahead? There's a little bit of delay, everyone. It's just how Michiko works with the.
Sorry, there was problem exists between keyboard and chair. I don't really see a lot of value in this proposal, in the sense that I think options are mostly useful to convey semantics. And this doesn't really give you any semantics. It basically has like a human readable description. It like clearly defines the syntax, but it doesn't say what the option means. It doesn't say what some implementation should do if it receives one of these. It doesn't say necessarily even how the fields are defined. Like maybe, I don't know, like if you have an integer lifetime field, is that milliseconds? Is that microseconds? What is that? So maybe that's, and so I think you're kind of going to need a document anyway. So at that point, I'm not sure what the use is of defining a common format, because I don't think that's a big part of the work in defining a new option. And I think if you look at the Pref64 option, and yeah, there happened to be some bike shedding over what fields were going to go where, but I think we would have had that anyway. I don't think it's true that in order to get this past the kernel, you need. I don't think it's true that this makes it easier to get this past the kernel. There are ways of doing this today. I mean, Linux has the ND user opt RDNSS facility where you can pass up arbitrary options. And I also, the first time we define some of these, now I'm going to have to go and find a CBOR parser, which I don't have. So I'd much rather write my TLB code, which I have libraries for already. So that's just as a sort of like implementation perspective.
So Lorenzo, how many implementations do you have of Pref64 in router operating systems?
We have one, but it's an SDN one. So yeah, maybe that doesn't count. I don't know.
I think that's what, one of the purposes here is to avoid that problem, right? Like we had with, especially the DNS option, for example, where it took many, many years before you had support in the network devices. At least in this scheme, the idea is to do that once on the router OS side, and then even.
But even there, just define get it from radius, because you're gonna have to get it from somewhere. Anyway, I suppose. I mean, I suppose it makes it easier if you're like literally typing the configuration by hand, perhaps, in the sense that you can type in the JSON and so on. But
well, the difference is, yes, you could certainly have a way of passing opaque TLVs, but this allows you, with the key space, it allows you to, to subscribe to messages if you're an application, for example. And you could also, as an application, just state that, please, Mr. Network, send me this set of configuration information, and it would purely be an action between the network operator and the application. At that point, you would take out changes in the underlying network infrastructure.
Okay, so we have a bunch of people in the queue, so why don't we move on? Jen?
actually going to say almost what Lorenzo was saying, that from we not just talking about option format, right? We need to know what the client is supposed to do and what kind of behavior I can expect from a client. So I'm a bit surprised to hear there is no IETF document required, because I think this part needs to be specified somewhere. Otherwise, I cannot reliably use it in the network if every operating system going to do something different with the option I said. However, I like the idea of being able to specify some random thing on my router without waiting for the new version release. Yeah, so I think it's a good idea, right? So I fully support the idea of the universal option format. I just still think we need to make sure we are on the same page about what it means for every participant. And yes, we do have at least one NASTIX for implementation on a router. Yes.
Yes, I mean this proposal is trying to design ourselves out to a job, and you know, we can yeah, it's future will tell if that was a good idea or not. Fernando.
Can you hear me?
We can hear
Yes.
you.
Okay, cool. So I have a question. So if I got your description right about the option, is that the main goal is to reduce the overhead that it takes to essentially specify new options. Is that correct?
Yes, part of it, yes.
Okay, so if that is the case, so my question would be if your assessment would be that the main overhead is in essentially the working group specifying the syntax, in which case I would agree that this would make a difference, or whether the main overhead is in specifying the semantics, in which case it wouldn't. So that would be, it's a question, not a statement. So my concern in a way is that if the main overhead is in the semantics, then, still we wouldn't be making much of a difference in that respect. And my other concern is that, if folks get to specify the syntax quickly and we don't get a document, then essentially I wonder, what would implementations refer to when, trying to specify this, when trying to implement a specific option. Okay, so there's a way for them already. If this is, if this document is adopted and published, there will be a way for them to specify the syntax of new options. But still, in order to be able to do something useful, they should be able to agree on the semantics. And if there's no document that specifies the semantics for the option, then, well, we have a, we would be having an interoperability problem.
I think I had, yes. I think I made that point as well. That's a very well-made point, Fernando. And
okay.
And that is why we started out with this as experimental, because we are what is the consequence of the IETF letting go, if you like, here, and we in a sense moving power from the IETF to implementers in a sense. But I was also suggesting to put in a safety valve that the expert reviewer could say hang on, the semantics here needs to be specified. This is so complex that you need an RFC document to get a code point here. So I don't know. I certainly share the same view as you. And sort of this came out of the IPv6 only debates we had, where we spent 2 years debating a single bit or a single flag and what it was supposed to mean. And I'm not sure, right? Perhaps it would have been better in that case to just specify the syntax, and then the implementations would evolve, into doing what was the right thing for them, right? It wasn't necessary that the IETF would have provided value there. But yeah, you're right. I mean, this. We don't know what the consequences are of sort of opening this up completely, right?
So let's say my concern is that, essentially besides the syntax, the, implementations need to agree on what they are doing with the option. So, part of my question is, if there's not going to be a document because, let's say implementations are relieved from that because they can already specify the option, where they still need to point somewhere. Would that be like, I don't know, a vendor website, an open source implementation? Still, I mean, even if it looks to me that somehow, the document, we'd still need a document. It just would be elsewhere, whether that's a website, a wiki, something. But still, if we want interoperability, well, a document is going to be needed.
So I think it depends, right? In some cases, and certainly, I certainly is not of the opinion that we should not have a document. Right? You can have, and there should be some stable reference, and it might be a document that exists already, or it might be obvious, right? If the option is here's the address of the encrypted DNS resolver, then presumably there are other documents you could reference that you wouldn't need the specific one for this option, for example. But yeah, I share your concern.
Okay, so we're a bit over time, so let's with two people in the queue, Dave Thaler and Michael. Dave?
So while I've been waiting in the queue, I have now 3 comments, and so 2 responses and then 1 suggestion. Lorenzo's point about not having a CBOR parser and so on mirrors a bunch of the discussion we were having in, I think, the suit working group for that one, where I was eventually convinced 2 things. CBOR parsers are really small because they're meant for even applicability to tiny constrained devices, and there's open source ones out there, so that's part easy. But the other point was, if you have a structure that you're encoding that's simple enough, like there's not a bunch of optional things, it's just, so the optional ones are those question mark colons, you can actually parse it with just a regular typedef struct, right? Because it's just a binary thing. And so it's actually flexible enough depending on how you define what option you're going to put in there. So anyway, other working groups have decided that that actually wasn't a problem, either that they could grab a CBOR parser that's only a very tiny number of lines of code, and so on. Other comment that was a response before I get to my suggestion is, I think the main overhead that we've seen in the IETF, or at least that I've seen in the IETF, Ole had on one of the first slides, which is people arguing about whether something belongs in an RA option or a DHCP option or both, and every working group gets into that debate. We said, oh no, not this again. So don't underestimate that. And then in many cases, the duplication of specifying both is twice the work of specifying one. And so I think Ole is at least cutting the work, Ole and Tim, or at least cutting the work in half, and probably much more than half. But it doesn't make the need for a spec go away. And that's what my last comment goes to. On expert review, so I'm going to make a suggestion, but on expert review, I happen to be the expert for the IF type registry, which is listed as expert review. And one of the requirements for the expert review, and that one is when you submit it to the expert, you need a pointer to a spec. It doesn't have to be a spec that's actually public. And so if you have a spec that's a private spec, as long as you're willing to share it with the expert, you can get the number. So now I'm going to get to what my specific suggestion is. Once you convert to CBOR and use integers for the keys, okay, integers that are smaller numbers are encoded in fewer bytes. Okay, so what I'm going to suggest is, if you say, let's use, say, IETF consensus to get any number that it can be represented in 2 bytes, and expert review with the specification needed for anything larger than 2 bytes. Okay, that means there's an incentive to get IETF consensus to get the efficient encoding, but it doesn't stop you from doing your own thing if you want to with a high enough number, as long as you go through expert review. So we've got other cases where we have 2 different, the low spit numbers and the high numbers have different reviews. And so my suggestion is IETF consensus or expert review with a spec for those 2 cases. But in neither cases, you need a spec. It's just another one, only the expert review has to see it. So if you have like an NDA spec or something like that, a non-disclosure agreement, you can still get a number for use on your routers or whatever. So that would be my suggestion. Thanks.
Excellent. Thanks, Dave. That's useful.
And by the way, there is a raise of hands for if you've read the draft going on. Okay, and I think Michael?
Hi, is it working? So I want to echo everything Dave said it better than me. But I also want to suggest that some of the discussion between Jen and Lorenzo in the chat, the real big problem, I think, for actually figuring out what the semantics are of the thing is actually letting people to build some running code. And we continuously get into this thing, well, we've implemented some new RA option, but it's not going to get out there or be usable until, 5 years of revisions of routers. And so I think that this lets people do some experiments easily and figure out this is useful, this is stupid, and come back and do things. So this really puts it into someone who has a client implementation, a host implementation that says, okay, I want to try this thing out. I'm going to get a number, and that's why expert review is appropriate and not spec required. And I totally think, yeah, a 3-byte number is perfectly fine for this kind of effort. And to figure it out and go, well, that actually wasn't very useful. I did this and this and this and this wasn't very useful, but maybe this other thing will be better. And if we can get that down to, 1 month instead of 2 years, then I think that's a really useful thing. And that's why I really think this is a useful process. Even if in the end, we actually go and re-encode the semantics in the traditional TLV format, the result of the experiment will be very useful, even if we wind up doing that. Thanks.
So, Bob, I have a question. If we should, if the working group would like to adopt this, but this is without my chair hat on, so it's up to you if you think there's enough people to.
Well, so the poll for reading the draft, there's 16 said they have, 3 they said they had not, and then out of a total of 93 people. So better than the last draft. I think this is very interesting work. I'm not quite sure we're ready to do the adoption call, or at least here. My take is that I sort of wonder if we end up doing specification required, then I'm not so sure that the encodings here are needed, because I think the idea of the encodings is to try to not have a spec. So I'm not sure how to reconcile those two things. But we are over time, so I think we should just go on to the next talk at this point. So thank you.
Thank you, Bob. Okay, so I have to go in and out of screen sharing again. That was weird. You can call the next speaker.
Edward.
There we are.
Yeah, just enable your audio and video.
Stand in the pink box.
There we go.
Do you hear me?
We can hear
Yes,
you.
we can hear you.
Okay, fine. Good day to everybody. My presentation here about the big leakage of information which we still have in MD. I am asking here evident for adoption, but I am asking for adoption of the problem, not the solution, because in solution definitely we have some number of trade-offs. For example, even internally within me in ShareBank, we have some dispute where to stop, because currently what is proposed here is conversion of the really big hole for in the middle attack to denial of service. And my partner ShareBank was not satisfied at all about this. He said, okay, let we do something more, let we make it maybe more complex, but maybe we could cut even denial of service. And okay, we have some maybe still some discussion possible here where to stop. Please go to the next slide. Okay, what we have here is a problem. The problem is very simple for intruder, because what is the essence of the problem? That even in the basic neighbor discovery protocol, if router will ask everybody who has particular MAC address, particular LLA link local address, who has particular MAC address for particular IP address, of course. The right host legal host will answer, but additionally intruder could answer just after, and because unsolicited unsolicited message could have raised bits for solicited bits, override bits. He could easily achieve the right cache for router, and the router after this will send, as presented here on the bottom of the slide. The router after this will send traffic, will receive traffic in upstream direction from the legal victim, but in opposite direction, the traffic will go through intruder. And additionally to this, if anybody from outside of this link will ask connectivity to this particular IP address, this particular IP address would be sent to intruder. It's a classical man in the middle attack, especially from outside. From outside is fully two-way man in the middle. From inside is one way, but because downlink could have downstream could have HTTP could have some DNS request, for example, and DNS request could be faked, and then it would become two-way man in the middle attack. In reality, this particular problem has one mitigation. We have the standard for so-called SARI, source address validation, and source address validation does mitigate this because on the switch on the layer 2 device, SARI snoop all ND messages, and if SARI is in question about who is the right owner, SARI could send neighbor solicitation to clarify which one particular owner is the right owner. Maybe I need to mention here that this particular problem is only about NSNR, neighbor solicitation, neighbor advertisement. It's not a problem at all for RSRR. I mean, for RSRR, I do not have here any discussion because we still don't understand what could be done better in addition to RR guard. RR guard plus this couple of standards is still assumed here as a prerequisite. Therefore, help from switch is still needed for RR protection, RS protection. Here is a discussion only about NS and R. Okay, please go to the next slide. The previous slide was easy for intruder, but if we'll block the previous problem by some means, and we have discovered it during this particular draft development that okay, we could block the previous problem, then additionally we could find some additional corner cases, which is more difficult for intruder, but even more difficult for us to protect, for standard or for developer to protect. The first one on the left is the situation which is not protected even by SARI architecture. It's the situation that for some legal reason the victim could be reloaded. It could be absent effectively. It could be absent, for example, hardware upgrade of the server, or maybe software upgrade and reload after this. It could be that the legal server is absent. And then at that time, couple of minutes, for example, at that time, intruder could claim his IP address, and because at that time intruder is only one who claimed this particular IP to MAC binding, of course, definitely he will pass any check. Doesn't matter what check he will do at that time, it will pass. Inside architecture too. Inside architecture, it's the same problem. And then after the server will be loaded, the intruder should just not respond to that. To that message, and then effectively intruder will be capable to claim his IP address on the router, and we will have exactly the same situation. One-way traffic will go from legal host to router, and the downstream traffic will go from router through intruder. And it's again exactly the same situation for traffic inside the link, and inside the same situation for traffic from outside. It's again man in the middle attack. It's one problem. And here his analysis that it doesn't matter is it grant enabled or not grant enabled, because if it's we have plenty of time for a couple of minutes after server go to reload with a couple of minutes, and it doesn't matter. The second in the middle problem, which is even more difficult for intruder, but even more difficult to block, it's a situation when intruder will not try to do anything bad up to intruder will see the DAD message. after intruder will see the that message, he will have retransmit timer 1 second, 1 second to persuade router that he is the legal owner of this particular IP address. And okay, if it's possible, a little bit different situation for grant and non-grant environment, but it's not a big change. It's exactly the same because 1 second is big enough even to send just normal legal traffic and to have traffic in return, and traffic in return will activate router to ask who is the legal owner, and intruder could ask, yeah, it's me, and that's it. It's again. In current proposition, we block all of this. We block not just previous one, which is easy to block, but even these two things we do block. And please go to next slide. We will discuss how to block.
By the way, I did start another hand raise thing for if people have read the draft.
Okay. The proposition, current proposition, is very simple in reality. Any change of MAC address in the neighbor cache, doesn't matter is it initial write or maybe rev write after somebody will send you unsolicited neighbor advertisement or solicited neighbor advertisement. Any change of MAC of LLR should be only as a result of multicast request, because we should give the capability for legal host to respond, and for us, for router, to see the duplicity, if it's duplicate or not. If this particular link is normal link where only one IP address is permitted for one host, one relationship to IP to MAC one-to-one, it's not any cast. If it's not any cast, then we expect that only one response will be on our any neighbor solicitation, only one neighbor advertisement response. If it will be two responses, then we will block both. We will block both MAC IP combination, MAC IP bindings. It's very simple. In reality, in the draft, it's a little bit more complex, more points than these 2 points, because in the draft, there is a little bit additional discussion that to block the last one problem, which we have discussed in the previous slide, the new host, after it will start, after it will finish that solicitation, after this, the host should send neighbor announcement about he should reveal himself. It's effectively grant, but grant in more strong form, because the override bit should be set. It's a little bit more complex than on this slide, but not much. What it gives? It gives, for majority of cases, no need for change of host. It's more or less simple. I show later next slide about details of implementation. Is more or less simple improvement for NT, and not very complex. We don't need for this NS and R any help from switch. No need for SAVI architecture, which does not help against the last couple of problems anyway. We have support here for any cast by the way that there is some counter which could be programmed in advance, and some configuration counter. And if this is this link where we have any cast, then we do expect more than one response to our NS, more than one NA will come to us. It has a little bit more multicast, but not much. In majority of cases, additional multicast will be 0, because in majority of cases, NS and our response would be used to check that it's really only one response received. In the grant environment, if we have one router, for example, there is analysis in the draft, then would be 33% of additional multicast, and if it many routers, then up to 50% of additional multicast. It could be the situation. It's deep analysis inside the draft. It could be the situation that a little bit more multicast is possible. Please go to next slide. I don't have intention to deep dive in details here. Of course, if you like, I could, but the improvement for state machine inside NT protocol is very simple. When you send neighbor solicitation from the host or from the router, you should effectively activate a couple of things. You should activate timer, for you to wait to understand which one responses inside the timer, which was one response is really response to your NS and which one is not response to your NS. You should activate the timer, and you should activate initialized duplicity counter, because it could be the link which has any cast, and then you do expect more than one response. A little bit complexity, not much, but a little bit additional complexity on the receive side. When you receive NA on the router on the host, then you should check first, is it response to your NS, or is it inside the timer, or is it unsolicited, and it's a little bit different behavior, is it solicited and unsolicited. The algorithm is here on this slide, and more details inside the draft. That's it probably, except maybe I need to tell what was the reaction to this. I have a couple of comments which is about implementation, which I definitely should follow. Yeah, I have a comment, for example, that I need to tell more in the draft about Savi architecture, because currently in the draft there is only story that this particular implementation does not create a problem for Savi architecture. It's completely orthogonal, that even if you will implement this, Savi would not be broken, and this implementation would not be broken by Savi. It could coexist. But it's not enough, because Savi is partially the solution. Therefore, I need to put here a little bit more text about Savi. The biggest concern was from a couple of people, from Philippe and from Fernando. The primary concern was about the problem itself, because they have assumed, effectively they both assumed, as I understand the same, they have assumed that because we still need the help from switch, we still need the help from layer 2, at least for RA guard, at least for filtering of router messages, RA guard messages. And because we need the help from layer 2, it does not make sense to solve anything on NS and R. Effectively, it was a message that any security problem of NS and R is a problem for layer 2 device, for a device which is below IP. It's questionable from my point of view. I do not accept this particular comment, because we still have currently the problem. We still have very easy attack vector for NS and R. We could really hijack, we could not hijack probably the current session, because current session could be encrypted in majority of cases, but we could be inserted in the middle, and after this we could collect all credentials, we could change DNS responses. It's really big leakage of information right now, which is really open. And because it's, if we will have a solution, some other solution, okay, it's fine, and then I would be silent. But the problem that we don't have a solution currently, it's a big leakage of information which is open. Now that's it from my side. Now it's question.
Okay, Jen, go ahead.
I have a clarifying question and I have a concern. So actually, I have a concern. Let's go straight away. Until this day, all work on neighbor discovery, all state machines were developed in the assumption that if we have duplicated addresses, that we should not disrupt already operating host, right? So if someone has this address, let the host to work, and let's deal with the newcomer and that duplicated address. What you suggested is drastically changes that approach. Now you're basically saying, okay, as long as we have duplicated addresses, doesn't matter if it's attack or not. Let's break everything. Let's break all participants and deal with that. And my concern here is also that I do not care about all these application layer like man-in-the-middle attacks, because each protocol should deal with it on the higher level. For DNS, we have DNS stack, right? We have encryption on the transport layer. I would not try solving man-in-the-middle attack on the neighbor discovery problem, because when you send your traffic to the internet, you never know if it's actually going to the intended destination unless you use some form of authentication. So I don't think it's worth solving on neighbor discovery level. And what you're doing here, you're replacing potential man-in-the-middle attack with DDoS attack, right? Now with that thing, I can easily disrupt any already operating host in the network segment by sending another neighbor advertisement, right? And putting that host neighbor cache entry into duplicated state, and everything would stop working for everyone. I am not sure in this situation the cure is not worse than busy. That's
Jen, not exactly like you said, not exactly this way, because the problem for duplicated IP addresses could happen only if we will have a real intruder in the subnet. The real intruder, I mean, if it would be just that, the DAT will never send your flag solicited, or the flag, the normal host, even after collision, will never try to install poisoned cache on your router. If somebody is trying to install poison cache on the router, it's really the evidence that you have the intruder. Therefore, this particular mechanism would be activated only in the presence of the real intruder. It could not be for any other reason. It could not be, for example, for police. Yeah. Okay.
I totally disagree, because you look at the all RFCs about duplicate address detection, optimistic that we need to work in the assumption that you, for example, can have hosts using UI 64-based interface IDs, and you might have people, I don't know, duplicating MAC addresses or manually setting IPv6 addresses on the interfaces, which can lead to duplicated. I've seen that in the real life, right? You cannot guarantee that you would never see two legitimate hosts having duplicate address detection.
Again, you misunderstood. Again, you misunderstood. No, it's not because duplication could not happen. Duplication could happen. It's no problem. Because in the duplication, if duplication will happen, nobody will try to rewrite the cache in the router. Nobody will try to raise the flag. Of override, of solicited. Nobody will behave like the intruder. Therefore, duplication will not activate this particular mechanism. This particular mechanism would be activated only if somebody will misuse NT protocol. If somebody will not just claim IP address, but he claim it with the flag override, solicited. So somebody will do something which is opposite to the standard.
Okay, so we're already over time. So why don't we have two Igors in the queue. Why don't we let them talk briefly, and then we'll need to move on. Oh, 3 people in the queue now. Okay, but we'll freeze the queue at this point.
So Igor Gartinsky first.
Yes.
Hey guys. So I kind of agree with Jen, but only kind of. So I do think that this is definitely a problem that should be, well, there's a lot of echo going on. So this definitely is a problem that needs to be solved, but I kind of wonder if this is the right approach. A different approach might be that whoever held the address the oldest holds the address, and then the router will perform, or not just the router, but every other node will basically perform validation. This was actually something that we proposed as part of the 6ND problem statement that we put out a couple of years ago. I think the idea of flushing the oldest and the newest is actually harmful, because that you can effectively DDoS an older node off the network.
But then you open the door for many.
Okay, we don't have time to have the interactive discussion, so let's get to the other two people in the queue.
Hi, Igor Lubashev. So just quickly, I see where Jen is coming from, and I agree that in my data center, I may actually be worried about duplicated addresses causing any sort of disruption to anybody. Now, I hear that there's a question whether it's actually even possible in a well-behaved applications. But in my home environment, I definitely would really prefer if some disruption happens rather than let my compromised DVD player basically man in the middle, unsecure, unfortunately still unsecure DNS responses to my laptop about like where Bank of America is. And so I can see it in 2 different environments actually having very different preference for availability versus security posture. That's my entire comment.
Okay, and then Fernando.
Focusing on any specific vector, I think that the first and most basic question one should ask is, what's the threat model for ND? My take is that ND depends on trusting the link. So if you mitigate one specific vector, but you still leave so many others to do exactly the same thing, the attacker will essentially employ whatever works. And in ND, if you want to mitigate all of them, unfortunately, you need to rely on stuff like SED, because you trust the ND messages after all.
Okay, well, thank you. I think we need to move on. Yeah, I mean, I tend to be sympathetic to what Fernando said. It's a LAN, and you can do lots of things on a LAN, and it's really, you can fix individual things, but there's just other attack vectors. But we should move this to the list. Okay, Dusan. Go ahead. Can you hear us?
We cannot hear you yet. We can see you.
Your audio was enabled, but
can you hear me now?
We can hear you now. Go ahead.
Excellent. Okay. For some reason didn't work right away. So this draft is about the use of least common scope during communication, and it's going to focus on on-link communication. Alexander and me worked on this together. Next slide, please. In the problem statement here, what we're seeing here on this diagram is that there are hosts different parts of the network, and we are going to focus on the hosts that are on the same local link, like in the bottom right corner, where we have host H, B, and HD. And there might be a need by applications to communicate on the local link using link local rather than global address, and mitigate attacks through the sockets if they open sockets using global addresses. So in most of the cases, as far as I know, communication is done using global addresses, and this draft is going to propose a solution where applications on the local link can decide to use link local addresses instead, even though applications are not aware of link local addresses in some cases or in many of the cases. Next slide, please. As we know, in 6724 RFC, the least common scope addresses are preferred during destination address selection. But socket API can be given only global address or list of global and ULA addresses, and there is no way to use this precedence if link local address is not present. In those cases, applications would use global addresses and for sockets, and open a socket to listen on global address and expose themselves to the attacks, potential attacks. Next slide, please. And here we have a proposal for a solution where in order to use link local addresses for on-link communications, we would like to propose a way to obtain a link local address for a destination, knowing global address that's on-link. And for that, we propose a link local address resolution as a way of obtaining destination link local address. Next slide, please. So what is link local address resolution? So it's practically an extension to address resolution where a host needs to obtain MAC address of the destination given global IP address. In this case, we propose that neighbor solicitation message can use extra link local bit, we call it L bit, to indicate that it's requesting a link local address from the destination. And it will send neighbor solicitation with the target address as global address, global destination address, and source address is going to be a link local address if this L bit is set. And neighbor solicitation destination address can be global address or solicited node multicast address. Next slide, please. So here is the proposed L bit, and we want to use this L bit to indicate that a source wants to obtain link local address because through this mechanism, because it knows only about global destination address and wants to kind of resolve this by using link local address resolution. And next slide, please. So the target will respond in this option, will respond with its link local address when it's requested. And by doing that, the source will obtain destination link local address and then can open a socket using its own link local address from the same link. So the communication can be done on the local link using link local addresses. So that's practically the end of this presentation. I'm open for questions.
Yeah, comments, please. And
Edward,
we also started a poll.
Edward, you're at the head of the queue. Please go ahead.
Are you on mute?
Edward, we cannot hear you. You're at the head of the queue.
You have to enable your audio.
He disappeared, so I guess there was a lag from the previous talk. Any questions for Dusan on this this draft? Going once?
Well, I have, I guess, one question. I mean, I guess I wonder if I understand this, it's basically to try to move more communication, local communication, to just use link global locals, so they don't have, nodes don't use a global address. But I wonder how useful that really is. Does it? I mean, it seems like a lot of devices are going to need global addresses to communicate outside of the local environment. So I don't know how useful this is.
Well, the expectation is that if we have a flat infrastructure within enterprises, let's say small, medium enterprises, we can keep all the local traffic inside using link local addresses, and it would be practically invisible to the outside world. So it would be secured very easily that way.
But aren't there a lot of enterprises already have ways of doing that? You know, a lot of people firewalls, and then we also have unique local addresses that keep stuff inside. Well, I know we have 4 other people in the queue. So Guyan? Go ahead. We're not hearing you. Okay, why don't we go to Ted Lemon?
Hi. So I just wanted to point out that whether or not you could ever even use this depends on how you got the IP address of the host to begin with. If you're using multicast DNS, you would already have the link local address. If you're using DNS, then you need to tell that the host is not on the link. So I just and your use case is kind of like giant flat network, which is the use case we don't really tend to recommend. So I guess my question is there a real problem to solve here? Like, is this something that we actually need to do, or is it just is there a better way to solve the problem?
Well, I think we lost Dusan there. Gian, are you here now? We can. Do you want to try? Otherwise, we'll go to Fernando.
Can you hear me?
We can hear you.
Okay. All right. Yes. So the question I had, I guess, was for this use case. It does seem quite a lot to do to resolve to mitigate an issue with global, I guess, reachability and leveraging the link local address. But I wonder if there's maybe other mechanisms, I guess, to mitigate this type of issue, maybe with ACLs or whatnot, that are already in place to get around this type of an attack vector. Especially because link local, there are other control plane protocols like routing protocols and whatnot, similar to neighbor discovery that use link local, but it's generally local. And I wonder if opening link local up to be used globally, if that would actually create a new attack vector, that may be unwanted. So that's all. Those are the only comments I had on that draft. Thanks.
Okay.
Thank you. Yeah, that makes sense.
Ted?
I think Ted, yeah, so when you're done speaking or leaving the microphone line, you can unclick your hand. I think, Fernando, you are next. Yes.
I'm trying to understand what is being proposed here. My understanding is that given that two nodes are on the same link, the authors want to essentially suggest that link locals should be used instead. Now, my question is that if it's for a local application, first of all, normally when you access a service, normally it's the result of mapping a name to the addresses, right? Then in that case, it could be an application policy to essentially, select the address of choice. Actually, we do have a specification for that. And on the other hand, if it's an application that is supposed to operate only on the local link, then probably it should buy a link local address or a ULA and not a global address. So I'm wondering if what they are trying to achieve here and whether that is really necessary.
Yep, that's a good point.
Okay.
Alexandra.
Yes, if you can hear me.
We can hear you.
Yes, let me try to say a few words answering to Fernando's question. First, I was wondering what is that application policy or a document that tells which source address to use, whether there is already such an application, then we would be interesting to look at. And then also Fernando says that application could select a LL or a ULA. Yes, it is true, but it depends also on the site deployment. If that site deployment has considered ULAs and has deployed ULAs, has auto-configured ULAs on these phones, because I think it's mostly about the phones, SIP phones in enterprises, then probably it could be also an idea to prefer ULAs instead of LLs. It all boils down to same scope communication. So if my destination is a ULA, then probably yes, prefer a ULA in the source. I think also, if I can continue on this, Ted recommended, asked whether there is a real problem here to solve. Indeed, it is a good question. The first one of the slides that showed the topology displays, I think, a real deployment into which indeed maybe flat networks are used, and but that's how it is deployed there. You would see on the right hand of the slide, there is a deployment with SIP phones at one site, and across the internet on the left side, there is another site which also has these phones, and there are SIP services deployed, and then of course one needs to talk to the others across the internet by using GUAs, globally unique addresses. But when opening a socket with a GUA, one exposes itself to attacks. So if I speak to a phone that is near me, why using a GUA? Why opening myself to attacks when I could just use a URL address? Okay, there is recommendations against giant flat networks. I agree, but I think it depends on the size of that giant, and if probably there are some Ethernet networks that could accommodate very many SIP phones in an enterprise, which would make it a flat network. So yeah, basically I wanted to give these comments as a reply to earlier comments. Thank you.
Okay, Fernando?
The kinds of attacks that you are trying to mitigate or prevent: attacks against the server, attacks against the clients, attacks against, for example, established connections between clients and servers.
I think against clients, mainly against clients.
No, but so let's say that you have an an off-site attacker, okay? So your concern is that the attacker would attack the server, the client, the established connection, or what else?
I speak under authority of presenter, but against clients again, attacks against clients.
But my concern is that if what you're trying to protect against is not attacks against the established sessions, but attacks against the clients, then it doesn't really matter what the client uses, because as long as the client has a global address, it is subject to attack. Because the client will still have a global address, so you're not preventing or recommending the client to use, let's say, link locals only.
True enough. There would be, but the attacks are different if the address is just auto-configured on the interface versus the address has an open socket on it.
Okay, but in the case of the client, it wouldn't have an open socket because it would be the server who would have the open socket.
SIP has multiple streams, I think, and some of them would be in a listening mode.
So my comment is that for the, essentially for the nodes that are listening on a socket, if you want to prevent attacks from, off-site attackers, just don't bind a global address. as long as you bind a global address, as long as you are using a global address, the address is going to be reachable. So the device is going to be, the node is still going to be subject to attack, even if clients are not using that global address. The global address is still there.
Yes. Yes, I think that might be right.
We are over time, so we have Ted and Jan in the queue. Let's do it quickly, and then we can move on.
Yeah, so just 2 points. One, the suggestion to use ULAs makes a lot of sense to me. I don't actually know why that's not what's being proposed here. And secondly, Alexandra's comment about the phone, the phone has to be reached somehow. You have to look it up somehow. So why not just fix the way you look it up so that you return an address that's appropriate, and then you can listen on that address and not listen on the GUA.
Okay, Jan?
Yeah, noted. Okay, noted.
Go ahead, Jen.
Jen. She dropped off. How about Eric?
Question: if we're concerned about not receiving communications for the service of link, why cannot we use generalized IETF security mechanism? Just do not accept anything with hop limit which is not equal to 255, and done. You can only get on link packets.
Or use the the 255 trick.
I must say I did not receive the question from Jen. Why not using what?
A security mechanism. Basically, what ND is doing, you always set your hop limit to 255, and you never accept packets if hop limit is not 255, which basically guarantees you that your packets are always arriving from on link. And as a result, you can use global address, ULA, you could use link local address, does it better. You can only reach the service from the on link client.
Okay, I know this question of 255. The hop limit. Okay, 255 must be the hop limit, and I note it down, and we will see about it. Yeah, thank you.
Okay, Eric? You're still in the queue. Do you want to talk? I guess we will assume not. Okay. Okay.
Hello.
Hi.
Can you hear me?
Yes, we can. Go ahead.
Yeah. Hi. Thank you. Hello, everyone. This is Jadong, and I'm going to present this document on carrying VTN ID in IPv6 extension header. Okay, these are the co-authors of this document. Next page, please. Okay, here are some background of this work. A VTN is defined as a virtual underlay network with the topology and the network resource required by one or group of services. And we think the information of the associated VTN needs to be carried in the data packet. This is used to steer the packet to the set of local network resource allocated to the VTN for the packet processing. And the VTN information needs to be processed on each hop along the path in the packet forwarding. So this document proposes a mechanism to carry the VTN ID information in IPv6 extension headers so that it can be applicable to both IPv6 and ISRS networks. Next page, please. Okay, here we give some analysis about the options of carrying the VPN ID in the IPv6 packet. The first one is using the IPv6 destination address. In this way, we need to allocate different IPv6 address or SRv6 seed per node per VTN, because this address will represent both a node and the VTN it belongs to. So this way, it will increase the complexity in the address management, and also it will increase the amount of forwarding entries in the data plane. The second option is the traffic class field. This was designed for the differentiated QoS treatment and is the ECN function. And we note that the value of the TC bits may be changed during the packet forwarding, which may not be what we want with the VPN information. The last point is within a VTN, we may still want to use the TC field to specify the different traffic classes. And the third option is the flow label. The flow label was designed for the load distribution among the ECMP paths or the legs, which means that the load distribution is a per hop behavior, while the steering of packet to the VTN specific resource need to be deterministic, and it should be done with a whole network planning based approach. So the last option we think is the extension headers, and it needs to be processed hop by hop in the data plane. So we have the hop by hop option header, and we can have a dedicated option type defined for the VTN information. Okay, next page, please. Okay, this page shows the mechanisms we used in this document. Basically, we propose to define a new IPv6 option type to carry the VTN ID. And the option type, the first two bits in the option type are set to 00, so that it can be skipped if unrecognized and continue be processed in the forwarding path. And the C bit is set to 0, which means it cannot be changed during the forwarding. And VTN ID field is a for architect identifier. This is to match the length of the network slice ID, the NISSAI as defined in the 3GPP for the 5G. Because the VTN option should be processed on each hop along the path, we think it should be carried in the IPv6 hop by hop option header. So the packet forwarding will be based on both the destination IP address and the VTN option. Okay, next slide, please. Here are the changes in the latest version. Okay, in this version, we clarify that we should use the hop by hop option header to carry the VTN option, because it needs to be processed on each hop along the path. And we removed the reference to the RFC 8754, the SRH, because the processing of the VTN option is independent from the SRH header. We also updated the operational considerations. More specifically, the processing of the network nodes on hop by hop header needs to be considered by the operator when they want to use the VTN option in their network, so that the VTN option should either be processed or ignored in the packet forwarding, and it should be based on this hop by hop processing information. The operator can avoid the packet drop due to the existence of the hop by hop header. Okay, next page. Okay, for next steps, we would like to collect more feedbacks on this document, and hope we can revise it and polish it accordingly to make it more stable in the next meeting. Thank you.
Good, thank you. Yeah, so I have a poll going about see how many people have read the draft. Are there any comments?
We have Ron in the queue, I believe. Ron, go ahead.
I have a two-part question. Two-part question. The first part is, does the VTN contribute to the next hop determination, or does it only determine which queue you go in on a hop?
Okay. In this draft, it is mainly used for the determination of the queues or like the logical interface. The next hop should be
when you say
determined by the destination address.
when you say the logical interface, you mean the VTN ID might cause a packet to go to a different next hop than it would have had the VTN not been there?
No, the logical interface belongs to the layer 3 interface, which is determined by the destination address field. We can have multiple logical interfaces under the one layer 3 interface. This is the one approach to separate the resources under the same interface.
Okay, I'm a little confused by your words. When you say the VTN ID determines the logical interface, in your mind, do all the logical interfaces on a node terminate at the same neighbor?
Yeah, for actually the forwarding is based on two steps. First step is you use the destination address to identify the neighbor or the next hop. And then you use the VTN ID to identify which which queue or which logical interface to send the traffic to the next hop.
Okay, if it's just next queue, yes, that's good. That's good. If it's just next queue, then we're okay. If it determined the next hop, you know, having a node skip it would run the risk of routing loops. But so long as you're not determining the next hop with the VTN ID, you're okay.
Yeah, I understand that problem. No, we will not use it for the next hop.
Okay.
Sanbin, you are next. Please go ahead.
Hello?
We can hear you.
Yes, we can hear you.
Okay, yeah. I add one point to the explanation to the Robonica, because this VTN ID is to identify the resource, is not to determine the outgoing interface, but a resource, it can have the different format. It means, as explained by the Jamie, it can be the queue. It also can be some the layer 2 interface is identified as the logical interface, etc.
Okay, Joel?
Seems to me that this assumes certain facts like knowing that the path you're following will be paying attention to this destination option that inherently require that you're using some other traffic engineering technique, either flex algo or segment routing or something else, all of which have the capability to implicitly provide any logical interface or queue selection that you need at whatever granularity you need, and adding an extra identifier to the packet seems counterproductive.
Okay, let me answer the question. You mentioned that flux algo or some other mechanism can be used for the traffic engineering, different traffic engineering purpose. Yeah, that's true, but that is in the control plane. In the data plane, you need different identifiers allocated for different flux algos. Like we have the segment routing based identifiers, we have the IP based identifiers just discussed on this yesterday. So this document just proposed the data plane identifier, which can be mapped to the control plane mechanisms for the traffic engineering. So they need to work together. Yeah.
But you said that this algorithm, that this identifier is not used for next hop selection. Therefore, this is not the identifier for flex algo. Something else is the identifier for flex algo. And that identifier can provide any needed traffic engineering. If this identifier is driving the flex algo, then this identifier is directly affecting the next hop selection. And then we have all sorts of other problems.
Yeah, okay, I see your point. You mean flash algo is for the routing can be used to impact the routing or the next hop selection, right? But even after you select the next hop, you still need some fine granularity identifier to select the resource used for to send the traffic to the next hop. This is why we need this identifier in the data plane.
Okay, Ron, and then we'll wrap up.
Having heard Joel's question, I'm more confused about the answer to my own before. I'm thinking that this VTN identifier is the moral equivalent of more DSCP bits. It's only used for queue selection, never used for next hop selection. Do I have that much right?
Yeah. Maybe I should make that clear in my answer to Joe. Yeah, we need the two identifiers in the data plane actually. One for the next hop selection, one for this, like more fine granularity resource selection. Is that clear?
I couldn't glean that from the draft.
Yeah, we can make that clearer maybe with some more text.
Okay, I think we need to wrap up. We're over time. So the next presentation is Linda Dunbar. Linda, so we're very close to the end of the session. I think it will let us run over, but if it's okay with you, we'd like to move you to the Friday session. Is that okay?
Sure. For the Friday session, can you put me on the beginning of the agenda because I have two more presentations at IDR happens at the same session with you, same time. So my slot in IDR is towards the end of the session. I think maybe
we can put you after the working group session presentations. Okay. So that'll be more, yeah. We're not going to use most of the time on Friday. Okay, well, good. Well, thank you.
Thank you.
All right. So I think
enjoy Bangkok.
Yes, or wherever you are, and if you're awake or asleep, I think this is only going to get to be more fun as the week goes on. So,
thanks a lot, everyone.
Thank you all very much. We'll talk to you again on Friday, or whenever that is.
Thank you all.